Okay, so here are those examples. Hopefully you've worked on them before you hit play. All right, let's look at number 1. I'm factoring because the direction said to factor, right? I have how many terms? Good, 4. So I'm going to see if there's anything I can divide out of all 4 terms. Do all 4 terms have something in common? The answer is no. If that had a 2, I would take out 2 out of all 4 of them, but it doesn't. If that had a t, I would take a t out of all 4 of them, but it doesn't. So, now what? Pair them up or group them up, same concept. So I'm going to leave it in the order they gave me, and I'm going to pair up the first 2. And remember, the second pair starts with what? The minus sign, because that 4t is negative, so to speak. So I need to make certain the minus sign goes with it. Cool? All right. So tell me, what's in common just with the first 2? Good, a t. How many t's? 2 t's. T squared. Got it. The second pair, they can both be divided by 2. I agree. The 2 would be what sign? Negative. That's why the first term on the second pair, you need to put the sign with it. Cool? All right. So take a look. You're factoring out a t squared from the first grouping. What remains? 2t minus t squared divided by t squared. 1. Wonderful. The second grouping, you factored out a negative 2 or a minus 2. Tell me what remains. Negative divided by negative is positive, so we have a positive 2t. And positive 2 divided by negative 2, negative 1. Excellent. Good job. Okay, so take a look. Is that a multiplication problem? Nope, which means we may still be able to factor. How many terms do we have? 2. Here's my first term, subtraction sign. Second term, terms are separated by multiplication, right? Okay. Now, do these 2 terms have anything in common? Gratefully, they do. If it's going to work out correctly, then these parentheses should turn out to be exactly the same. I'm not going to force them, though, because sometimes when I actually do this technique, sometimes the 2 parentheses don't match up to each other, which means I can't take it any further than what I've done. So just remember that. Don't force it. If they work out, they work out. All right, so you decided to take out a 2t minus 1. Tell me what remains. Good, these cancel, so you're left with t squared minus 2, because these drop out to a 1. Yes? Okay. Ooh, t squared minus 2. What do you think? It's a squared. We might be able to factor it, huh? Okay, so let's just do a quick check in our brain. What's in the middle? 0. So if I do 1 times negative 2, we multiply and we get negative 2. The only combinations that multiply to negative 2 are these two combinations, right? Do either one of these combinations add up to the 0 that's in the middle? Nope. Because technically I have nothing in the middle, which means I have no combination to replace the 0. So this would be my final factored format. And I'm just trying to erase the 1 so it looks nicer. Yes? Yes. Good. How about number 2 here? How many terms? 4. Is there anything in common with all 4 terms? Anything I can divide out of all 4 terms? Is there a number? Is there a variable? Nope. So what are you going to do? You're going to pair them up or group them, whichever terminology you want to use. Remember, the second pair has to start with the sign because the 6t is technically negative. Agreed? All right. What can you take out of the first pair? A t to the power of 3. Add the second pair. Well, it's definitely going to be a negative, whatever you take out, right? And it's a 3. Both of them divide by a 3. Ready? Okay. I have t to the third. What remains out of the first pair when you take out t to the third? Good, a 2t. And out of the second pair, a minus 1. Excellent. Took out the minus 3. Okay, tell me what remains. Yes, this will be positive. This, negative. Oh, that's coinky-dink. You're like, what's that? It's a coincidence that these turned out to be somewhat the same with the 2t minus 1 in the parentheses. Okay, so let's see. Anything in common? Yeah, 2t minus 1. So, and if you need to write the lines under each term and put 2t minus 1 under it, then please do, okay? So when you take out the 2t minus 1, tell me what remains. T to the power of 3 minus 3. By the way, working with colors also makes it a little bit easier to see. Okay, I have a multiplication problem. Are we done? Look, there's a t to the third. Let me give you a hint. If this is going to factor, t to the third means it's a perfect cube. That means this second number better also be a perfect cube. Is 3 a perfect cube? You're right, it's not, which means that's not going to factor any further. So we're done with problem number 2. That's it. Cool? Cool. It's only the square that I can actually take it just a little bit further to see, but that has to be a perfect cube also. Problem number 3. Okay, take a look. How many terms? 4. Excellent. Anything in common with all 4 of them? Oh, Okay, that's a 3, that's a 12, that's a 6, that's a 24. Yeah, I can take a 3 out of all of them. Anything else? Oh, they all have A's. Okay, how many A's can I take out of all of them? Yeah, only A to the power of 1, because this one is the fewest, and that's all I can take out of that one. All right, so let's see what remains when we do that. By the way, the 3A is still out here, so remember, you're not getting rid of it yet. So, A to the power of 3 minus 4A squared minus 2A plus 8. Good. Excellent. Okay. I still have 4 terms inside here, don't I? Which means you could probably still factor this by grouping. Now, here's the deal. I don't want us to get confused with this 3A here. It still needs to be here. So I'm kind of going to do some side work over here to help myself out so I can just put the result in place of this big parenthesis. So a cubed minus 4a squared minus 2a plus 8. Okay, what are you going to do? You're going to group them up. Got it. What are you taking out of the first group? A squared. Out of the second group? Negative 2. Very good. So, tell me what remains. Took out an a squared. You have a minus 4. Good. Second pair, you took out a negative 2. That's a positive a, and that's a negative 4. Okay. You have 2 terms, don't you? What can you take out of them? That's right, the parenthesis of a minus 4. What remains? A squared minus 2. Excellent. It sounds like you're getting the hang of this. I'm glad to hear it. It's not too bad because it's almost like a little sing-song pattern. Because it seems like we just keep doing the same thing over and over. Different numbers, but that's okay. Whoops, I wrote something incorrectly. Hold on. Hold on. Okay. All right. Oh, I have a square here. This is multiplication, but I got a square here, don't I? Possibly factors? Yes, but I'm noticing this was a t squared minus 2, and even though the variables are different, the process is the same. Did t squared minus 2 factor? Nope, then neither will a squared minus 2. Good? Okay, I have a couple more examples coming your way, so stay tuned. Okay, so here are those other two examples. Did you work on them already? Great. So look at problem number 4. Tell me what you did first. Good, you identified there was 4 terms. Excellent. Then what'd you do? Anything in common with all 4 of them? Well, that's a 2, a 5. Well, already that's a no because the 5 messes it up. There's no y's in common with all 4 of them. So now what'd you do? Yes, you paired them up. So what'd you take out of the first pair? Y to the power of 2. What'd you take out of the second pair? Good, you took out a negative 8. What'd you take out? Some of you said 2, but you can go higher. Some said 4, but you can still go higher. Some of you said 8, but you can still go higher. 16. Like, how'd you know it was 16? Well, if I kept breaking it down and seeing what was left over, I'm noticing I could go higher than 8, and 32 was 4 times 8, but 32 is also 2 times 16, right? So you kind of have to play with the numbers sometimes when you get a little bit larger. Good? Okay, so let's see. You took out a y squared, then you end up with 2y plus 5, right? You took out a minus 16. What remains? Good, that's a positive 2y. And what's a negative 80 divided by a negative 16? Stay off the calculator. Stay off the calculator. Good, plus 5. Good. Getting the hang of what's going to factor out here? I hope so. And again, if you need to put those parentheses under each term, because you do have 2 terms, right? If you need to put the parentheses under each one and then write what's going to factor out of each one, then please make certain you do that because it's important to do what works for you. Cool? All right. So you took out a 2y plus 5 and you have a y squared minus 16. Done. It's multiplication. You're like, the y squared plus 16. Yeah, I know. It does factor, doesn't it? Because they're both perfect squares, right? Okay, remember that little side work. Y squared plus 0y minus 16. There's a 1. There's a minus 16. That gives you a negative 16. What are the numbers that multiply to negative 16? There's a few of them, aren't there? But remember what you're looking for. You're hoping one of these combinations is going to add to a 0. And that adds to the 0, doesn't it? Which means you can replace the 0 with this combination of a positive 4y and a minus 4y. You can do the same grouping technique that you've been working on, and you will notice that this will factor, and you're like, you're going a little fast. Pause it. The same exact technique. Pause it. And you will notice that this factors to the quantity of y plus 4 times the quantity of y minus 4. This still factored. It factored to 2y plus 5. But this y squared minus 16, y plus 4, and y minus 4. This is the grouping technique we've been working on for the last 5 problems, including the lecture, and ready to be 6. Cool? This is all the same that we've been doing. Good? Good. Excellent. Okay, we've got one more here. Talk to me. What are you doing? Good. You first identified that it was 4 terms. Then, could you factor anything out of all 4 terms? Well, let's see. Could you? Any numbers in common? Nope. And they don't all have an M, so you can't factor out an M out of all of them. Okay. So, yep. Pair them up. Group them up. Here we go. What are you taking out of the first pair? M to the second. Second pair, definitely a negative. This one's a little more obvious, right? Yeah, 25. The 16 may not have been as obvious, but 25 and 50, yeah, you guys have worked with those often enough. So you took out an M squared and M plus 2. Excellent. You took out a minus 25 and positive M plus 2. Wonderful. Okay, what are you taking out of these 2 terms? You're taking out an M plus 2. What remains? M squared minus 25. Excellent. Are we good? Okay. Done? Nope, not finished yet. This is a square. It's probably going to still factor. And I'm noticing that m squared minus 25 is very similar to y squared minus 16. Very similar. And if I do that whole process of 1 times negative 25, I get negative 25. And technically there's a 0 in the middle, right? So wouldn't that be a positive 5 times a negative 5 that adds to 0, but multiplies to negative 25? So couldn't this be rewritten as m squared plus 5m minus 5m minus 25? Some of you are like, hey, there's a shortcut to this. Well, honestly, the shortcut came from first you doing it the long way. So make sure you know how to do it the long way, because you're going to need it for trinomials. Anyway, when you group them, when you pair them, you are going to notice something that looks like this. But different variable, different number. That's okay. You basically have the same, almost the same answer because it's the same technique. I should say it's the same pattern. Perfect squares attached by subtraction. It ends up to be a pattern. And it's in another video. We do more of them. You see it a little bit better. Okay. These 2 are really good. You may not have been able to have factored anything out of all of them like we did on problem 3, but you had to take the answers, or what you thought to be the answers, and take it one more factoring step. Good? Okay, hopefully you had fun with this stuff. Catch you on the flip side.